Hey everyone, have you ever wondered how OpenAI can predict how powerful their next AI model will be even before they train it? It sounds like magic, but it's not. It's something surprisingly simple and super important. It's called scaling laws. Scaling laws might sound technical, but the idea is actually really simple. Once you get it, you will see why AI has advanced so fast in the past few years. Scaling laws are basically simple rules that tell us how an AI model gets better as we scale three things. First, model size. How many parameters it has. You can think of this like the model's brain size. Second, training data. The number of examples it learns from. That's its experience. And third, compute. The energy, hardware, and the time we use to train it. And here's the cool part. When you increase any of these, the model's performance improved in a really predictable way. It's not random, it's not magic. It follows a smooth curve that we can measure. That's what makes scaling laws so powerful. But here's something important. Bigger isn't always better by itself. There's a balance between the model size and the training data. If your model is huge, but you don't have enough data, it's undertrained. If your model is small, but you feed it tons of data, it cannot fully learn. You are wasting effort. DeepMind figured out a simple rule, the Chinchilla scaling law. To train a model efficiently, the number of training tokens should be around 20 times the number of parameters. So for example, a 10 billion parameter model usually requires around 200 billion tokens. It's all about hitting the sweet spot, the right size, the right data, and the right compute. Scaling laws are simple, but they are incredibly important. For example, they let companies predict performance before spending millions on training. They help avoid wasted compute, like training a model the wrong way. In addition, they explain why GPT, Cloud, and Gemini work so well. It's not luck, it's design. Basically, scaling laws turn AI progress into something predictable, not guesswork. However, AI performance doesn't scale in a simple straight line. Doubling a model's size doesn't double its performance. Instead, AI tends to follow smooth, power law curve. Each increase gives you a smaller boost than the last, but the boost is still predictable. So as models get larger and larger, the gains slow down, but they don't disappear. That's why even training parameter models are still worth training. Scaling laws are super useful, but they definitely have limits. They work great for large language models trained on text. That's where they shine. But they don't really tell us much about things like reasoning or planning. And once you move into multimodal models or agents that use tools, the patterns don't hold as cleanly anymore. Same with alignment and safety. Those improvements don't follow simple curves. And here's another big one. Data quality matters a lot. A smaller, cleaner dataset can sometimes beat a massive, noisy one. So yes, scaling laws explain a lot, but they are not some universal rule for intelligence. Here's the conclusion. Scaling laws are simple, surprisingly predictable, and they are a huge reason AI has gotten so good so quickly. In general, if you have a model if you give a model more parameters, more data, and more compute, it performs better. Not perfectly, not in a straight line, but the trend is incredibly reliable. But as we talked about, scaling laws don't explain everything. They are a big piece of the story, not the whole story. If you want more clear, simple breakdowns of AI and tech trends, don't forget to like and subscribe. Thanks for watching.